ladies and gentlemen, we need to take a look at lesson 6.1, and we're going back a little bit and picking up polygons. We like doing triangles back to back. What we're going to do is identify and describe polygons. This should be some review from maybe elementary and middle school, just refreshing our vocabulary, and then talking about finding the angle measures of quadrilaterals. So our vocab. A polygon is a figure that is formed by 3 or more intersecting segments. So the segments have to intersect. They have to join at a point. When we talk about a side of a polygon, it's the segments that make up a polygon. So we're going to have 2 endpoints because they're a segment. The vertex is the point where the segments intersect. It's a corner. So when we take a look at this, we can talk about something like a parallelogram. So this is a side. It has 2 endpoints. All right, we may call this A, B, C, D. So AB is a side, and the vertex is angle B. It's an angle. So the angles make up the vertex. It's where the 2 sides intersect. So CB intersects AB at that point. And then we have diagonals. The diagonal of a polygon are segments that connect non-consecutive sides. So AB and BC are consecutive sides. They are one right after the other as we travel around the outside. So we're looking for segments that connect sides that aren't already connected. So AB and BC are already connected. Non-consecutive would mean not connected. That's another way to think of it. So when we look at our diagram, one of our diagonals would be DB because D and B are not connected to each other. And another diagonal would be AC. What I put here is that we normally find those inside the polygon. So what we want to do is we want to draw a polygon A, B, C, D. If there's 4 letters, 4 letters, that means there's 4 sides. So we're going to go A, B, C, D. So I want you to name all the vertices. There are 4 of them. I want you to name all the sides. There are 4 of them. And there are 2 diagonals. So I want you guys to do that. And we will check. In class. So you guys need to do now and check in class. Let's take a look at example 1. We want to know, is the figure a polygon? Remember, it has to have 3 or more sides, and the sides need to intersect. They need to be segments. So, number 1, we've got these sides here, as we trace that around. So it is a polygon formed by 4 straight sides. That's pretty important to keep in mind there. B is not, because the polygon has a curved side. All right, so this curve here is our violator. And then C, no, the figure is not a polygon because it is not closed. Two sides do not intersect. So our problem is right here. These 2 sides do not intersect at a vertex. So our follow-up, this is where our review comes up. This will be something that you guys might need to. I'm going to give you the number of sides, and then you're going to sketch a polygon. A triangle. Tri is 3. Quadrilateral, we think of a 4-wheeler, 4 sides. Pentagon in Washington, D.C. has 5 sides. Hexagon is 6. Heptagon is 7. And octagon is a stop sign. So what you need to do now is you need to sketch the polygon on your own. And you're going to do that now. All right, so let's take a look at example 2. We want to describe these polygons. Is it a polygon? And if so, tell what type. If not, so it's similar to what we did before. So A, it says yes. It's a figure with 4 sides. 1, 2, 3, 4. And so it is a quadrilateral. B, yes, because everything's closed, everything's straight, so we count 1, 2, 3, 4, 5. If we go back and look at our chart, 5 sides is a pentagon. And if we look at C, no, it is not, because 2 sides intersect at a point that is not a vertex. You cannot have sides intersect. Notice they're not meeting, they completely cross. So this side crosses this side. So we can't have them intersect like that. They can only meet at an endpoint. All right? So checkpoint 1. All right, decide whether there is a polygon. If so, tell what type. If not, explain why. So you are going to do now. All right, let's take a look at theorem 6.1. It's the quadrilateral interior angle theorem. What that tells us is that the sum of the measures of an angle of a quadrilateral is 360 degrees. We're going to do a little kind of demonstration here in a moment to show you that. But we need to know that every quadrilateral has 360 degrees. And so what that means is if we take angle 1 plus angle 2 plus angle 3 plus angle 4, it should equal 360 degrees. So just like we knew a triangle had 180, we need to know that a quadrilateral has 360. So we want to do this next follow-up together. It says draw quadrilateral ABCD. 4 letters, 4 sides. So A, B, C, D. So A, B, C, D. And then divide it into 2 triangles by drawing diagonal AC. So I'm going to connect AC. So here what happens. The sum of the angle measures of triangle A, B, D. This triangle here, inside that triangle is 180 degrees. We know that from chapter 5. The sum of the, actually that probably comes earlier in the book. And the sum of the angle measures of triangle ACD is also 180. And so because both those triangles are found inside our quadrilateral, we know that we can add those together. So 180 plus 180 is 360. That triangle demonstration is going to come in handy because we're going to use that later on in this chapter. But if we know we can divide in triangles and then count up how many triangles we have, it's just adding 180 each time. But what we're going to do, it's pretty easy to remember that quadrilaterals have 360 degrees. All right, so if we take a look, find the angle measures of the quadrilaterals. So I need to find the measure of angle S. Well, I know that if I add up all of the angles, it's going to equal 360 degrees. That's that quadrilateral interior angles theorem. So I'm going to substitute all of the angle measures I know. I know angle P is 70 degrees. I know angle Q is 80 degrees. I know angle R is 70 degrees. So I'm simply taking the angle measures from the diagram. So once we add an angle S, that should equal 360 degrees. When I look at adding those together, 70 plus 80 plus 70 is 220 degrees, plus angle S will equal 360. You're simplifying that. You're going to solve by subtracting. You're going to solve for S by subtracting. The 220 degrees. So when we minus 220, we get angle S is equal to 140. I'm going to use a little bit of my reasoning. This looks like an obtuse angle. 140 is an obtuse angle. So, ladies and gentlemen, your job is to do now on your own the checkpoint. You want to use example, sorry, let me write that a little bit better. You want to use example 3 to help you. All right, best of luck, and we'll see you in class tomorrow.